Hi, today I got an email that one of the proposal that I sent for giving a presentation at the Strasbourg DevFest has been accepted, so which is good because I visit Strasbourg very quickly a few times where I was directed to Stuttgart and got there by train with a stop in Strasbourg. Sometimes I spend the night there. It's very beautiful, so I look forward to that. It's not the easiest place to reach from Turin, but that will be fun. But the presentation that got accepted is about our approach for migration pipeline. So when we need to transform some code from one programming language to another, typically from a legacy programming language to a modern programming language, we do that through steps that are part of a pipeline. And we do that because, guess what? Migrating a language is complicated. So by splitting this process in steps, we can get everything right. We can inspect the intermediate points and verify, we are heading in the right direction, which is exactly the opposite of what I've seen some more, let's say, naive language engineers do. So I saw people, try to put together some regular expression. You read this, change a little bit, and immediately print out the result. Surprise, doesn't work. So we use instead a pipeline approach where, we start with an empty system. First step is loading some files into the system. Second step is parsing. Third step is what we call semantic enrichment, which is a combination of symbol resolution and type calculation. Then we have different kind of analysis. For example, we may identify dead clones, we may identify clones, we may identify idioms, we may classify how the goto are used, and so on and so forth, until we have a step that consists in creating new AST in the target language. Maybe for RPG file and an RPG AST, I can produce, for example, a Java AST. And finally, we have the final step that consume this AST and produce the actual Java file or Python file or whatever. So this is the approach, and this is based on LionWeb, this framework, or should I say standard, or let's say this common specification for creating language engineering components. And there are a few advantages. So the system is designed so that we can create each of these steps in different languages. We mostly use Kotlin, but we can create components in Python or TypeScript, for example, or in C#. But we can also consume the results produced by this element from these other languages, which is convenient because, for example, we can have this pipeline producing information, for example, annotating the AST with the result of some analysis, and then we can have a component in TypeScript that accesses this information and visualize it inside a web application. Or we can have a Python notebook producing some quick visualization or generating a report with some stats. So that is something that can be done. Also, because we support, or we're based on LionWeb, we can store a snapshot of this pipeline in a LionWeb format, and we can store it as a file or into a database or whatever you want. So we have a few advantages. The idea is that we have this Starlasu Pipeline Processing system that we can use to perform analysis or to perform migrations. It just changed the kind of steps that we involve. Typically, a migration has everything that an analysis pipeline has, plus some additional steps to produce the final result. So each point in between each step is called a snapshot and can be persisted so that we can, for example, explore the differences between two steps by looking at the snapshot before and after that step. Each step can be involved different components. Each component has a name, has a version, and they're logged inside this snapshot. So we know that this snapshot has been produced by 3 steps. In first step, we use this component. In second step, we use this author, and so on. So this is useful also for reproducibility, also for logging. And we have then a component called the orchestrator, which is the one that invokes the single components in the pipeline. And we typically write most of the components in Kotlin, so the system, the orchestrator runs on the JVM, but it's important to notice that we do not take all these components, for example, an RPG parser or an RPG to Python transformer. We don't include them as dependency to create the pipeline. So we have the orchestrator, which is a process which dynamically load the other components through a special class loader, so they can use different version of, and potentially conflicting version of the libraries, and they can still work together. So it was a little bit involved and it requires some optimization, but it's working. So right now the system is working. Of course, it must be refined. Of course, performance must be improved. And another thing that we want to do is creating a dashboard to visualize the internals of this system. So yeah, we're doing some progress. By the way, the presentation at DevFest Strasbourg will be in November. So, you know, we have quite sometimes, you know, the temperature must go down by at least 20 or 30 degrees before we get there. So, yeah, some work to be done, but I think we're heading in the right direction. So I look forward to visit Strasbourg. I look forward to write about the Starlasu Pipeline Processing System. And thank you. If you have any comments, if you have any questions, if you have any feedback, of course, reach out or write a comment here. Always happy to read any of your feedback. Thank you and have a great day.